We move to the last speaker, this second part of the morning, Professor Litov from University of Sofia, Bulgaria. Please.
This one, okay? Just give me a sec. With the one below. No, with this one. This one. No, the other one. This one. Yeah. Okay.
Okay. So, okay, I'll take it. Okay. First of all, I'd like to thank the organizers for the invitation to present our project, but actually this project was already mentioned many times. So I simply will try, this simplifies my task, and I'll try to present the project in a systematic way. So what is behind the abbreviation SEEIST? You see here is Southeast European International Institute for Sustainable Technologies, a little bit long and strange name, but this is so. The idea to build international intergovernmental organization in the region of Southeast Europe was proposed by Hedwig Schopper, former director of CERN. After that, the basic idea behind it is with the help of this center, to promote collaboration between science, technology, and industry, to provide platform for the development of the education, of course, to boost the technology transfer from European laboratories, leading laboratories like CERN and others, to the institutes in the region. Our region is a little bit, from political point of view, difficult. So the other goal is to mitigate tensions between countries in the region, and of course, to form a research nucleus in the region of Southeast Europe. But because we are speaking about a research organization, and this is the first very important point, we should remember this, this goal can be achieved if we build a really unique scientific infrastructure. Okay, I'm sorry. So what are the countries which are behind this project, participating in the project? They are listed here. Roughly speaking, these are the former Yugoslav republics plus Bulgaria, Albania, and Greece. You can see them on the map. The project is based on two, so we already commented that when we are speaking about a project of this size and scale, the politicians are important. So it's based on two documents. The first one is Declaration of Intent signed at CERN in 2012. The history of the project was quite well covered by Sanya. This document was signed actually by, at the beginning we had 10 countries, 8 countries. Croatia declared that they are going to sign the document at referendum, and Greece declared that it's very interested in the project, but they will join the project as observers. Fortunately, in 2021, Greece signed this document also and joined the project as a full member, and now is one of the most active participants in our project. I'm really sorry. So the second document was signed by the Prime Minister of 6 out of these 8 countries. And as far as I know, the Greek Prime Minister also is ready to sign document if this is needed. Now, at the beginning, the basic idea, what we were considering 2 possible options. In both cases, to build a big accelerator. In the first case, to accelerate electrons and produce synchrotron light. And the second option was what we have now, to build an accelerator for protons and light ions, and to use it for treatment of tumors and biomedical research. Just a few words, what were the arguments behind this choice? What is shown here are the data for 3 of the Balkan countries, Bulgaria, Croatia, and Slovenia. This is the number of new cases of cancer as a function of the time. You see that there is a very clear trend of increase of the new cases. It is okay, more or less natural nowadays. It's almost everywhere. This is the situation. But I also would like to show another picture, which is the mortality ratio. And what is shown here in red are the countries from the region compared with the other countries from the European Union. You see that in our case, the situation is much worse. And the reason behind this, one of the main reasons, is that there are 2 reasons actually. First of all, is the late registration of new cases. And second is that not all options of treatment of cancer are available for the population in the region. To demonstrate this, you see the map of Europe, and as you can see, starting from Vienna to Moscow and from the Baltic countries actually to South Africa, there is no single proton center in this strip or ion center for treatment. So this is why we decided to try to build a center which is devoted to cancer treatment. We'll get more information from Mimosa later on concerning this number. Now, of course, the first question is, do we need this type of center, and what is the number of expected patients, for example, if you are considering the treatment? So the population of the 10 countries which are part of the project is the level 43 million. If you add, for example, the Balkan part of European part of Turkey, it's already 75 million, and here is not included, for example, Romania. We did a very careful estimation of the number of the expected patients, where practically all different types of cancer, time of registration, first registration of the cancer, the protocols for treatment, and so on, and national protocols for radiotherapy, by the way, which are quite different in different countries, were taken into account. The result is that you can give a lower minimum of expected patients, 1,400 patients for this 43 million, or 2,000, almost 500 patients for the region of Balkans. This estimation strongly depends from the national protocols, and they are changing, by the way, as well with the time. So this number should be considered as a really lower limit of expected patients. The SEEIST center will be not able to cover the needs of the region. This is definitely an obvious thing. Now, thank you to Mauricio. We already know what we are planning to have, what type of accelerator. Let me remind you, we start with the ion sources here, then we have a LINAC, after that cyclotron, after that we have 3 treatment rooms, one of them equipped with gantry. And what is important, however, and it's not typical, so to say, is in this case that we have a very big experimental area which will have 2 beams, and these 2 beam lines actually can be divided additionally to 2 or 3. So we have this experimental array, and again, I would like to remind you that the first task of this center will be research. Now, concerning the parameters of the accelerator, they were covered. I have 2 slides. This one is for the people coming from the medical. This is for the physicists. but actually we have the same parameters of the accelerator. I'm not going to list them, but look at the first row. So we have what we plan to have as ions, which will be accelerated. We hope that we will be able up to oxygen to accelerate ions. The energies more or less are standard. However, what is important is the intensity of the beam. So we do expect to have 10 to 10 protons per spill, or for 10 to 8 carbon ions. And this is open the door really to be able to give a very big dose for a short time. And this is another very important peculiarity of this accelerator, that we have the standard slow extraction of the beam, but also we have a fast extraction beam, which opens the door, for example, to do research in the field of flash therapy with this machine. We already saw this picture. There are different options. So this is one option of our dream. By the way, so we have two buildings, but what is important is the second building, where is the accelerator, the treatment rooms, and the experimental area. Good. The next question is, how many patients we can treat per year? The very important condition in our case is that 50% of the time, daytime of the beam should be used for research, and this applies some limitations. But in any case, taking into account that we have 3 rooms, excellent. 3 treatment rooms, we do expect to work at the level of 250 days per year, 30 minutes per fraction. So we do expect to be able to treat about 400 patients per year. Again, actually, this is a lower limit. I think that there are many options and ways to increase this number, but not too much. So the cost of the project, we did a very careful estimate of the expected cost of the project based on the experience of now, Medustron, and all knowledge which you have concerning building this type of installations. The estimate is 250 million euro for everything. However, this estimation was done 3 years ago. Now, you know that during the last years we have big inflation and so on. Now, again, the situation is more or less stable, so we are going to update this estimate. A very important question is sustainability of the project. So this is the running part of the project, how we can fund the work of the center. What we need, again, using the current knowledge, is the level of 18 million per year. Half of them can come back as an income as a result of the treatment of patients. And something like 8 million is expected to be the contribution of the member states in the project as a yearly contribution. It was already mentioned by Mauricio that actually our project is wider. So we plan to have this central facility with accelerator and everything else, but also we plan to have hubs. And these hubs should be and will be close connected to the central facility. What we are discussing are digital hub, accelerator development hub, scientific, in this case, radiobiology means, sustainability hub, training, animal research, and imaging hub. This is under discussion, so not yet fixed. We have no final decision. Stages of the project, the current status, we have, so roughly speaking, 3 phases: the preparatory phase, construction phase, and training phase. So the preparatory phase, we have 2 stages. We are at the second stage, working on the TDR of the project, fixing the legal framework for the establishment of the institute business plan, and so on. The construction phase will take 5-6 years optimistically, and we hope that we will be able to run at least 30 years this infrastructure. The timing, this was our plan some years ago. Unfortunately, as a result of COVID, war in the Ukraine and many other things, like any other big project in Europe, this also is late, at least by 2 years now, comparing with our initial plans. But okay, we continue to work and hope that we will succeed. So this was already discussed. The project is well integrated in the European environment. As I already mentioned, the research is main mission of the SEEIST project. We have several unique things which we can use for the research. First of all, we have this experimental house. We have high duty cycle linear accelerator. It was already mentioned, by the way, that we are going also to use this accelerator for production of isotopes for treatment, patient treatment and diagnosis. We will have the most advanced accelerator technology, including the possibility to do flash therapy and to do research in this field. The center will be working a large number of scientific and technical staff to support the investigations of the researchers. By the way, what we are going to do is to apply and to use the research model of CERN. This is the way to organize the research at the center. I have no time, but just to mention, so the basic idea is that first we will treat patients, but they will be enrolled as clinical trials. One of the major directions will be development of new protocols and methods for cancer treatment. Other direction is combined radio and immunotherapy, for example, radiation genetics and radiobiology. This morning we saw that there is a lot of questions which are waiting for answer. Of course, all aspects of medical physics, new materials, nuclear physics, by the way, low energy, isotopes for imaging and cancer treatment. So, roughly speaking, this is the program. Current status, I already mentioned, we are at the level of preparatory phase. We hope that next 2 years we will be able to complete the TDR for the project. Otherwise, legal framework is already fixed. The business plan is ready. Okay, we should update now it, but what is important, the site of the central infrastructure is not selected yet, but we are preparing this process. I hope till the end of the year we will have everything ready to do it. Thank you very much for your attention.
Thank you, Professor Litov. A question for the status of the project, please.
Leandar, this is a really very ambitious project, and it's well structured and well prepared. You mentioned this 250 something million. Do you include also the hubs?
No, sorry. No, the hubs are not included in this number. For the hubs, they estimate that we will need additional 10-15 millions. Okay, not like this. This is first point. And second, the plan is that the hubs will be in different place, not where is the center.
No, this I know, but I was just wondering if this 250 are...
I missed to mention this.
No, it's okay. Thank you.
Other? Okay, if not, thank you again.